welcome to my kitchen. Today I want to talk about making a carbonated beverage. So when you make a carbonated beverage at home, you have to inject some carbon dioxide into it, and then maybe add a little flavoring if you like, and then you get these lovely effervescent bubbles, and it has a nice taste to my mind and a nice mouth sensation. So I enjoy a carbonated beverage. Couple of interesting things to start with, though. First off, one of the things that we'll find is that when you carbonate water, it changes the pH. It makes it more acidic. So you form carbonic acid in the water, and it becomes more acidic. So just as part of that demonstration, I have here some tap water, and I'm going to take a pH test strip, dunk it in the tap water, let it react a little bit, and then if we hold it up to this camera I have here set up, you can see that some of the pH test strip turns green, which we kind of match up. You see right on the tip there. It's turning green, which we match up to a pH of 7, which is what you would typically expect with tap water. So tap water has a pH of 7. So we'll mark that right there. And this should be a capital H there, because the pH stands for the concentration of hydrogen ions, which is hydrogen ions are what cause acidity. Now, we want to carbonate this, and I've got here a soda stream carbonation device, right? So commercial carbonation device that you can buy for your home, and it will easily carbonate many, many liters of water, just like this container here. In that is a cylinder of carbon dioxide, and this carbon dioxide here cylinder contains 60 liters of carbon dioxide, according to the label here. Now you might say, well, that doesn't look like 60 liters. I mean, a liter is about a quart, so that would be about 15 gallons, right, of carbon dioxide. And what they mean here is that this is 60 liters of carbon dioxide if we allow it to expand into its gaseous form. It starts out, well, you can't hear it here, this one's empty, but it starts out in a liquid form inside the cylinder. And so, but in its gas form, it would expand to about 60 liters. So when you let that go, it shoots out of this canister, and it would fill this room with carbon dioxide, which wouldn't be great for me. We've got plenty of ventilation, but we're not going to release that much all at once. What we're going to do is we're going to take this bottle here, right, filled with tap water, has a pH of 7, and I'm going to put it in my soda stream here. And I'm going to adjust my overhead lighting so you can see this a little bit better. Okay, so now I've got my my view set a little bit differently. So you now see the water bottle that I have here, I think. Oh, there we go. And you see it in looking it straight into the camera. And in it now, it's in the device, and there's a tube running down from where the air canister is, the CO2 canister is connected. And I'm going to press this button up here, and we're going to see CO2 bubbling into this water. And so I've injected a bunch of CO2 into the water. The top of this canister is actually at higher pressure now. It's above atmospheric pressure. So when I remove this, you'll hear a puff of gas as the gas gets released. And you should also watch for some bubbles generated in the water. So here we go. I'm going to remove it. So, all right. So now the pressure of the water bottle is back down to room temperature. Some of the CO2 has escaped, both from the where the pressure was higher and where but also from the water itself where the CO2 had been dissolved. So I'm going to switch back so you can see what's going on here. Okay, so we're back in our overhead view. I've got my water bottle of carbonated water. I'm going to pour out another glass. So we have our tap water. That's at, and you should be able, I think you can hear that. I hope you can hear that. You can see it's nice and fuzzy and fizzy now. And now I'm going to take another piece of my paper here, my test strips. Dip that into the carbonated water. And now, instead of being a nice green color, it appears to have moved over. It's at least a pH of 6, if not closer to 5. So, but it's not certainly not this green that it was before at a 7. So I'm going to call it a 6, I think. So adding the carbonation, lowers the pH of this. So I'm just going to add a little bit of shrub in here, a little ginger citrus shrub, just to give it a little bit of flavor. Take a nice refreshing sip. And that was Science in the Kitchen, carbonating water. See you next time.